Okay, last four examples are just on rectangles, so let's take a look. Here we go, example 6. We know in rectangle RSTU, we have segment RT, which is a diagonal, is 5x minus 14, and US is 2x plus 10. What do we know about the diagonals in a rectangle? They're always going to be congruent. So all we need to do is set 5x minus 14 equal to 2x plus 10 to get started. Alrighty, so subtract a 2x, we get a 3x on the left. Add 14, we get 24 on the right. So x equals 8. Now, does that answer the question? Unfortunately, they do want us to find segment VT. So VT is what piece of a diagonal? VT is this section. It's only half of one of those diagonals. So to find that length, what would I need to do with my x? Doesn't matter which segment I use, but I'm going to have to plug it into one of my segments and then divide it by 2. So let's plug it into 2x plus 10 because it's slightly straightforward math. And then I have to take that answer and divide by 2. So 2 times 8 is 16. 16 plus 10 gives me a 26. And half of 26 is 13. And that is my length of VT. Alrighty, example 7. So I have 2 angles marking in the corner. But what do I know about the corners in a rectangle? All the corner angles are always going to be 90. So all I need to do is add those 2 angles up and solve for x. Now, before I do that, let's read the question. So in rectangle GHIJ, find the measure of angle GHI. So the angle they're looking for is this one. So once we know what our answer is for x, how are we going to use our info to solve for that angle? Well, which angle is congruent to that top angle up by h? If you use your alternate interior angles, it's the same as the 3x plus 2 angle. So once we solve for x, just plug it back into that piece. So here we go. So 3x plus 2 plus 12x minus 17 has to equal 90 degrees because they're in one of the corners. So add your like terms. We have a 15x, 2, and a minus 17 gives us minus 15 equals 90 degrees. Add 15 to both sides, and we get 105. And divide both sides of your equation by 15, and we get 7, lucky 7. So to find angle JHI, we just need to plug into 3x plus 2. So 3 times 7 plus 2, otherwise known as 21 plus 2, aka 23 degrees. Again, appropriate for the size of the diagram, we've got an acute angle out of our work. Alrighty, example 8. So in example 8, again, it's the same kind of problem we looked at with our parallelogram. We've got a piece of info labeled, but not everything kind of matches up with the same triangle. So let's see, if we're trying to solve for x, and I want to think of, well, where else can I put that angle? I'm looking at all of my options. So I'm going to label these all with a dot. I could say that this angle, the bottom half of D, or angle GDH, that one's equal to 5x plus 7, but doesn't really get me close to the 134. And same thing, I could put it on the opposite sides. It doesn't really help me out. But what if I knew this angle in here? So if I'm looking at this nice straight line that I've got here, and I've got that top portion is 134, what should that add together with that double marked angle that I just put in the diagram? They make a linear pair. So if I subtract from 180, so subtract that 134 from 180, I get out 46 degrees. So that adjacent angle that makes up that linear pair, that's 46 degrees. You seeing yet what we might be able to do with that isosceles triangle? All the angles in every single triangle always add up to 180 degrees. So I can add 5x plus 7 plus 5x plus 7 plus the 46 that we just figured out. And those all add up to 180 degrees for the interior angles of a triangle. Combine your like terms. We have a 10x plus a 7 plus a 7 plus a 46, aka 60. This is shaping up to be a very straightforward problem now. Subtract 60 from both sides. We'll have 10x equals 120, and then divide both sides by 10, and we get 12. Does that answer the question? Yep, said solve for x, so we are done. Alrighty, last problem. In rectangle STUV, we know that SW is x squared, and we know that TW is 2x plus 3. How should those two pieces compare to each other? Well, if diagonals are congruent and the diagonals get bisected in any parallelogram, including rectangles, then that means those two pieces need to be equal. So we're just going to say that x squared equals 2x plus 3. And it's another one of these where we need to factor out and then set each factor equal to 0. So move everything on one side. I'm going to move everything to the x squared because it's already positive. And then factor it out. So if you want to, again, check your box factoring with this, but I know that there's only one way that I can actually set this up. If I have two factors, and the first two factors have to multiply to make x squared, I know each one is an x. If I'm thinking about that -3 at the end, well, the only way to divide up a 3 is 1 times 3. And so how can I turn the 1 and the 3 into a -2 for the middle term? Well, -3 and +1. Again, this doesn't always work. So if you want to, go ahead, pause the video and use your box method to make sure that you can get the same factors out. Okay, and then once you get those factors, again, each one is set equal to 0 to test which one could be the factor that makes the whole equation 0. So x plus 1 equals 0 and x minus 3 equals 0. Plug them back in, or excuse me, solve out for x. And we have either x is -1 or x is +3. So we should test both of these just to make sure. So if we have, let's see, an x squared, we know it's going to come out positive with a 3, so let's check with the -1. And in fact, whenever we square a negative number, we always get a positive number back out. So if you plug that in your calculator to double check, just make sure you type your parentheses around that -1. Same sort of thing, let's check the other value. So 2 times x plus 3, or otherwise known as 2 times -1 plus 3. And that comes out to -2 plus 3, aka 1. And so we haven't actually answered the question yet. The question was, figure out VW. Well, where's VW? So VW is itself one of those kind of half-piece diagonals. So either one of them, it really doesn't matter which one we choose. We still want to figure out what our possible answers are. So let's see here. We have one possible answer. We got out a 1 when we plugged in a -1, but let's go ahead and plug in that +3 and see how our numbers change. So we could have our x squared, aka 3 squared, or 9, or we could have 2 times 3 plus 3, which comes out to 6 plus 3, also known as 9. So just like we had 2 answers for x, we have 2 answers for our possible lengths. So VW could be either 1 or 9. Alrighty, if you need to, okay, definitely do check out the extra examples. These are clickable links if you open up the file through Schoology. Let me know if you have any questions, and if not, start working on your practice.